it will not be on tape, but Whitney's name will be on tape forever now on YouTube. Never mind, Whitney. We're moving on. Jared's been a pain, and I've had enough. All right. Yes, YouTube. Yes, now you're catching on. All right, on this one, the first one. I wonder if it can record me from all the way over here. I'll find out. It's pretty sensitive, actually, I think. The first one. Hopefully you know that complementary means 90. So 90 minus theta will give you your answer. I'm going to do this one on the calculator. The other day I did it manually. New, show high, there we go. That's quick. Just to review where some of the buttons are. Mode would be in degrees. There we go. And then I would take 90 minus 36, second angle, 58, second angle, 2 is 26, second angle, oh sorry, it's not there, it's under alpha, then plus. Alpha, then plus is your seconds. And then when you get your answer, you can go back to DMS by hitting second and angle DMS. You get 55 degrees, 1 minute, 34 seconds. So we talked about those buttons before. The exact radian measure of an angle, that's just using your conversion of 180 and pi. The 990 goes here. The theta goes right here. You guys can work ahead if you want. I'm slow because I have all this stuff on here. 990 divided by 180. Math frac. So that's going to be 11 over 2. Solve for theta, I multiply by pi. Now I get 11 pi over 2. Okay? Sound good so far? Central angle. On this one we said you can do one of two things when you're talking about arc length and area. I said you can do geometry or you can do trig. For geometry, arc length was theta over 360 times 2 pi r because that's a fraction of the circumference. On the trig, I said it was r times theta, and we worked it out because this is in radians, and this is in degrees. I don't know, I'm kind of a radian type person, so I'd put 3 equals 3 times theta, so theta will equal 1, and make sure you realize that's in radians. Then it says find the area of the sector. Well, again, I gave you 2 choices for that. I said you could use your geometry formula of theta over 360 times 2 pi, oh sorry, times pi r squared. Pi r squared. Or I said you could use the trig in radians of 1/2 r squared theta. I get a feeling most of you would not remember the trig one, so I'll just go ahead and convert this real quick to degrees and get my answer and use a geometric one to show you it's going to be the same thing. So I'll take 1 times 360 divided by pi. Sorry, it should be 180. 180. I got different orientation over here doing it like this, so it's kind of messing me up. 180 divided by pi. So my angle is 57.3 degrees, we'll call it. If you would have solved it up here, you would have solved this, you would have got 57.3 degrees. I did it earlier in the other class, but their video went bust, so that's why I'm making this second one. So the area is going to be 57.3 divided by 360 pi 3 squared. And you have a calculator, so hopefully you're going to use it. Divided by 360, fractional part, times pi.
times 3 squared. And you end up with 4.5 centimeters squared. Okay. Sound good? 6.8? No, somebody came in yesterday and asked about that, and I said that had to be a mistake. Okay, because I did it both ways. Number 4. What? Is that Whitney again? Now her name's on YouTube twice forever. Nice. All right. The wheels on the bus go round and round. Actually, this is a car. Like a little Olivia car, not like a big smoking black truck that some people drive. Anyway, the diameter of this is 23 inches. Speedometer says 55 miles per hour. There's lots of ways to do it. You just want to see how fast the tires are rotating around. So you have to stick your head out the window as if your windshield is frosted up and you're trying to count the number of revolutions. Okay? All right. So, I don't know. Probably circumference is needed for something, 23 pi. That's of your tire. And I've got inches here and miles per hour here, and it wants to know revolutions per minute. Well, it's pretty easy to see that hours are going to change to minutes. That's not too difficult. 1 hour and 60 minutes. The miles are going to change to inches. It's just a question, do you want to do this all at once or do you want to take your time? 1 mile, 5,280 feet. I know that's true. And then the 12 feet, the 12 inches are in 1 foot. So I got 12, 5,280 feet, so I have 1 feet and 12 inches. So these are two separate ideas. I'm not using them together right now. So if the car was traveling at 55 times 5280 times 12 divided by 60. Those are all nice numbers to come out even. 58,080 inches per minute. So if the car is traveling at 58,080 inches per minute, and your circumference is 23 pi inches, how many revolutions will it be making per minute? How can you find it? Yeah, I was going to say you just divide them, don't you? So you take that and divide by 23 pi. Big warning right here, make sure they're both in parentheses, not just one of them. Otherwise you'll get a mistake. It comes out to be around 803.8 revolutions per minute, or 804. Sound good? There's lots of ways of doing that problem. That's just one way of doing it. Number 5. Pendulum on the clock. Pendulum, they used to have clocks without electricity, believe it or not. They were on pendulum power. You push them and they'd go for a while. 3.5 feet. Swings out an arc of 8 inches. That's obviously very dramatized for the sake of showing it's an arc. Approximate degrees. So do you want to use your geometry or do you want to use your trig? It doesn't matter to me. What do you want to use, A1? Geometry? Which are you going to remember more? Probably geometry? Okay. So S equals theta over 360 times 2 pi r. But you have to have everything in the same units. So you want to go inches or feet? Inches? All right. So the arc length is going to be 8. 8 over 360 times 2 pi. What's the radius in inches? 42 inches. So, .91 degrees. Sound all right? Okay. Sounds good to me. Let's go with number questions. Am I going too fast, too slow, or is it all right? I want to keep Graham interested, so I got to, that's a fine line to, sorry. YouTube. All right. YouTube video. Forever. That's it for that page. Number 6. A couple ways of doing it. I think we've already done number 6, haven't we? A couple days ago you did it. Some people use the reference triangle. Riley, do you remember the reference triangle? Huh? Alright, what side is opposite? What side's the hypotenuse? 2, right? What's the long leg? √3, and the short leg opposite of 30 is going to be 1. So is this 21? Is this the long leg or the short leg? Yeah, it's the long leg. It's opposite of 60 degrees. So there's 2 ways to find this. 1, you can use your reference triangle, or 2, you can whip out the big tangent, 21 over y, and figure it out like that. So there's 2 approaches. Using a tangent or using a reference triangle. Makes no difference to me. If you're going to use your reference triangles, you have to find your scale factor. What do you multiply this long leg by to get 21? Whatever that number is, you multiply 2 by that same number, and you multiply 1 by that same number. So what's the scale factor? What are you multiplying by? So √3 times what equals 21? So you divide by √3, right? Sound good? Rationalize it. So 21 divided by 3 is going to be 7. So your scale factor is going to be 7√3. So every number is going to be multiplied by 7√3. So you have 14√3 here and 7√3 here. If you did the tangent way, you'd solve y tangent of 60 equals 21. So y equals 21 over tangent of 60. You have to be in degree mode, of course. Still am. .124. So, which number is that? Is that 7√3? It's not 14√3. You just check it. And it is 7√3. So you know y is equal to 7√3. And do the same thing for x, because you have 2 choices for 7√3. Okay? And for x, you would do probably sine. But everybody in the room knows the answer is going to be, I think, B. Isn't it? Yeah. Sorry, should have been right there. Yeah, so you could have done this one also. Falling over X. So far so good? How did he get in? Ram! Closed and locked. I get scared very easy. Alright, redwood tree. Here we go. There's a canopy, there's a tree, it's kind of crooked, that's okay. Straighten it out. There. Nice looking tree. Here's a Forester. Okay. .210 is the height of the tree. Base of the tree, sorry. And then measure the height to the top. And it's 64 degrees. How do you find the height of the tree? Which ratio? Yeah, it's tangent. We actually did this on my geometry concepts. We went outside and measured angles of elevation and find the heights of the trees by the four-way and the school and stuff like that. No, absolutely not. I'll never do that again. I had kids in trees. I had kids on that monument. I had kids on the back of the picnic tables. They were all over the place. That ain't gonna happen.
If it does.
Sure.
All right.
All right. So, what'd you get for H? What? What'd you get for H? What? 430.6? Sounds good. All right, what mode do you have to be in to do cosecant of 1.25? Radians. How do you type it in? On your calculator. 1 over sine of 1.25. Okay. Mode. I'm just getting ready. 1 divided by sine of 1.25. Okay. Now, this next one, I told you to put on your note card, and all the cool kids that didn't want to, now you'll see why, because on there I told you how to factor a perfect cube. Good thing you use that note card for reference. You reference enough, you remember, and you practice. So how do you factor x cubed plus y cubed? X plus y squared. Okay? So applying that same logic to this question, you have sine of theta plus cosine of theta times sine squared of theta minus sine theta cosine theta plus cosine squared of theta all over sine theta plus cosine theta. So what can you do with those two factors that are multiplied in the same? You can. One last thing. The number one Pythagorean identity to know is what do you get when you add these two together? You do get 1. That's how the kid got all the extra credit that were on TV holding that sign about girls basketball. Woo woo. Okay? So, that means your final answer is going to be 1 minus sine theta cosine theta. The Pythagorean identities are the ones to know. They are the big ones. Moving on. See this negative? that invokes the X and Y definitions for trig. This is X, this is Y, this is theta, and this is R. So what's the definition of tangent on this new axis we talked about? What's the opposite of the adjacent side? Y over X. What's sine going to be? Y over R, opposite over hypotenuse. And I told my ACT prep class that my trig students knows that this symbol means is positive. Okay? Is positive. So, all that information brings to the fact, if Y is positive and Y divided by X is negative, what's X have to be? It has to be negative. So, which quadrant do I draw this out in? Yep, X is negative, Y is positive, and I label it. 5, negative 12. What's the square root of negative 12 squared plus 5 squared? 13. And there's theta. So you have to figure out which ratios these are. And it looks like, is it A? Looks like A. All right. Unit circle brings us our other definitions. What's the definition of cosecant of t? 1 over sine of t. And on the unit circle, what is sine of t equal? On the unit circle, this definition changes. Y, X, and 1. So what's the sine of t going to be, or what's the cosecant of t going to be? Sorry, theta. Should put t right there. So what is it? Sine of t is going to equal y over 1. So cosecant of t is going to equal 1 over y. What's the y coordinate in this problem? So 1 over 8/17 equals the cosecant of t. So it's 1 over 8/17. If you fractionalize it, what do you get? 17 over 8. All right. These questions, these are very calculesque. Do you remember to put 0 in first? That's your first move, and you hope you get an answer. What is 1 over the cosecant of 0 equal to? That's number 1. You put the number in first. And what do you get? Error. Step number 2 means you graph it. The window is crucial. You want 0 to be in the middle on this one. So you're going to have pi over 2 is your x max, and negative pi over 2 as your x min. You remember what that little negative means? Right there. Any ideas what it means? I think we're going over this then. What's wrong, Olivia? Sorry, my remote died. That's okay. I'm moving on. What does it mean? Yeah, it means it approaches from the left when it's negative. So we're going to be approaching 0 from the left. If it was positive, we'd be approaching 0 from the right. Okay? But we're not. So we are going to approach it from the left. So to the calculadora. I think that's Spanish for calculator, isn't it? Yeah. Nice! See, I speak Spanish. 1. Oops, this is wrong. It should be sine. 1 over sine of 0. 1 divided by sine of x. The window is determined by the problem. Negative pi over 2. Pi over 2. And I'll just leave pi over 2 as that. I just put negative 3 and 3. It doesn't matter what you put in. What mode? Radians. Y equals 1 over sine of x. Graph it. Pi over 2. Are you in radians or degrees? Radians, check. Y equals 1 over sine of x. And then your window, negative pi over 2 to pi over 2. Huh? Okay. So as I'm approaching 0 from the left, what's happening to the graph? Graph is going down. Which one of your choices means it's going down? C. Questions? Fantastic.
I'll stop there and do one more. I'll do 2 more, and then I'll stop and we'll take the phone. Okay. And I'll record it with my newfound, if I might, oh, I just maybe. So you want to do this on the calculator? Y1. Sorry. Y1, Y2. What does this tell you? This 4 pi is your x maximum. This is your
X minimum. This is your, what's your scale going to be? I always use pi over 2. Okay. This time I'm not going to use the patented Colberry move of intersect. You'll see why in a moment. So 0 to pi over 4, or 4 pi. Negative 3 to 3, got it. Y equals sine of x. Y2 is 1/2. Okay. Graph it out. I want that thing to go away. There we go. Alright, so one of my choices for this was pi over 2. So I'm going to check it. Second, calculate value pi divided by 2. And I should get out 0.5, right, if it's a true statement. But that cursor's not on the graph and the line at the same time, is it? So A is out. Second, check pi over 6. Second, calculate pi divided by 6. Second, calculate value pi divided by 6. You see it equals 0.5? So it's going to be one of these three. Which one should you check next? 5 pi over 6? Second, calculate value. I mean, I could do it all the way, but you get a bunch of decimals. 5 pi divided by 6. That works. So it's down to, so this one's out. Next, I'll check those. I should have an answer. I'll check 13 pi over 6 first. Second, calculate value 13 pi divided by 6. Now I got 0.5. So I know this is going to be the answer. You can do second calculate intersect, but you're getting a bunch of decimals, and you won't know which is which. Okay? All right. Last one, then I'm going to stop. 5 plus a sine b x minus c. Remember the 5 usually goes in the D spot back here. So that's D. C in this case is going to be what value? Yes.
13 says
D?
yeah,
Do they match up all the way?
that's what I got.
Wait a minute. My first one I checked was pi over 6, wasn't it?
Yeah.
So pi over 2 is out. So it's pi over 6, 5 pi over 6, 13 pi over 6. There we go. That'll work. Thanks. There we go. All right. Because I verified those. All right, so C is 0. What's B? What's the number in front of the X? 1. And A is 1. So we'll start at 0. 2 pi over B. So I'm going to end at 2 pi. And here. All right, so what's D to the graph? Moves it up, right? So there's my D. What's the amplitude? 1. So I'm going to go 6 to 4 and put in my 5 dots. And all you have to do is figure out which one that looks like. Looks good. I know the other ones are, well, that one's moved down. That's not good. All right, so it's going to be C. Okay? So tomorrow I'll go through 15 through 17. Okay? Now I got to hope the recording worked. All right, stop right here.